Okay, it's 2 p.m. already, and we have 21 people. Let's wait 2 more minutes. Okay, I guess we should start now. Okay, it's 2-2.
Yes, yes, not a
First
problem.
of all, yeah,
Yes, yes.
definitely. First of all, how many were present in last webinar? So just to get an estimate, how many people are new here? Okay, Aryan was there, +1. Four, 5, great. Okay, so most of us present today did not attend the last webinar, right? Okay. So just to give a brief idea, this is not a general webinar. Okay. I won't be discussing any college related stuff. For example, types of questions asked during the exams, how to room scan and everything. This is a machine learning. You can consider a webinar. You can consider it a lecture. So first of all, let me share my screen and give a brief about myself. I hope you are able to see the screen, right?
Yes, the screen is visible.
Yes, Komil,
Yeah,
we can see
26
the screen.
members, great. So my name is Komil Parmar. I am from cohort 2. It is second year, it means, right? I started machine learning from class 10. However, if I talk in terms of computer science, I started from class 8. First, I started with 3D modeling and VFX. Then I switched to ethical hacking and still did not find kind of a passion there. So in class 10, I did a course in AI and then started into machine learning. So in 11th, 12th as well, I was doing ML alongside my high school. And finally, I joined this online degree to continue my journey in ML. So you can read a detailed journey here. Okay. By the way, I'm doing this degree standalone. It means not with a parallel degree. And the reason being is that since I was doing from class 10, I was mostly aware of all the concepts taught till the second or the third year, and hence didn't wanted to waste time doing them and going through them again officially. So I joined this online degree so that I can utilize my time better. Okay. So you can also connect with me through LinkedIn. Okay. I keep posting many machine learning related resources as well as the experiments I conduct. Now, the agenda for this webinar today is to give get an idea of how to apply machine learning in real world. Now, those who joined later, I mean recently to the group that I created, I have hosted a competition, a machine learning competition, which is beginner friendly. And I am teaching how to join the competition, how to make progress, how to run some models, test them, and all these things from scratch, starting from scratch, right? So this is the competition. Uh, let's go through this. First, when I share you the link today after this webinar, the first page you will get is an overview. You will get the timeline here. Now, since many of us did not join the previous webinar and hence didn't were not aware of the competition, if you believe that I should provide some more time, I can do that. Okay, I can shift the timeline by, let's say, giving 4 to 5 more days, if you think so. Okay, so you can decide and let's discuss that at the end of this meeting. Okay, so don't worry for the timeline right now. Go through the description of this competition. I will be sharing the same. Most important is the evaluation metric. Okay, so what do we have to do in this competition? I have provided 3 Excel files that are CSV files. First is the train.csv, second one is the test.csv, and third is the sample submission.csv. The objective is that in this data given, there are samples of concrete created using different amount of components. Okay, so when I'm creating a component of, a sample of concrete, there are lots of components that I have to mix, and each of them can be added in different amounts, right? So in this data, I have provided there are a total of 8 components, okay, like the cement component, blast furnace slabs, fly ash component, and all these. There are a total 8 components. The age of the concrete sample in terms of days and the concrete sample that I hence created using this mixture of all the components. The strength of that concrete component is given at last. So using machine learning, you have to train models that will use these amounts of components added and the age in days and use these features to predict this target column strength. It means predict what will be the strength of the concrete sample created using this mixture of components. I hope that was clear. Now, if I
Okay,
go
so
to,
Komil,
yeah,
I have a doubt if I can ask.
yeah, sure, sure.
Like, so we need to predict them. Like, it is kind of a regression based task, right? Like you have to predict the value of
Yeah,
strength, or
exactly. So there are 2 types of tasks. One is classification, where you classify a sample into one of the n categories. And then there is regression, where you have to predict a continuous value, right? So definitely this is continuous value. So you have to predict the strength. It is a regression task. Hence, I will also show how to apply linear regression and solve this task and how to make your first submission to this competition. Okay, so if I go to the column section, you will see the details of all the columns present in the train.csv file. You can see that there are 10 columns present here. Okay, first is the ID column. The rest are the amount of each of these components present in the concrete sample that is created. So each row is a separate concrete sample. Okay. And finally, there is strength. The good thing about this data is there is no missing data present. It means everything is filled. You do not have to deal with any missing values. Okay, it is completely clean. So you can directly start training models and making submissions. Okay, so if I go to test.csv file, one thing you should notice is that there are 9 columns and not 10. What is missing here? So definitely this is test.csv file. So the label are not given. Label it was the strength column, right? It is not provided here. You have to use these features. You have to use your model that you trained using train.csv file and ask your model to predict the strength of each of these samples, uh, the samples that are provided in the test.csv file. Now, once you generate this strength column, you have to put that into sample submission.csv file. So as you can see, the strength column is present here, and there are only two columns, ID and strength. Rest of the features are present in a test.csv, right? So this is the submission file that you have to submit to the competition. And I will show you how to edit this, how to train a linear regression model, how to use it on the test.csv file, and then store the result into the sample submission, and then generate a submission.csv file and submit. It means it is going to be end-to-end detailed. Okay. So also one more thing, in the discussion forum, you will find a few discussions that are specific to this competition. If you have any doubts, I recommend, or you have any knowledge you want to share, I recommend that you do this using this discussion forum. Okay, so if I go to this first one, Ajit here have made a concise description of each of the components that are present. Definitely, I am not a civil engineer, nor I hope, nor is one of you present here, right? So just to get an understanding of each of the components or the features that are present, he has created this description of variables discussion. You can also share some ideas, or you can keep the discussion going, writing some comments here, right? Same way, there is one more discussion done so far. Like someone has mentioned, Ratan Singh. I think, yeah, he is present here today, I guess. So he has asked a question like features. Should we use them all? Okay, and I have also write a small answer to that. You can go through this. So all such discussions, I recommend that you put them here. Then comes the leaderboard. Okay, so this is the current leaderboard. There are 15 participants already. I hope most of the others will join after this webinar, right? So one more important thing is that this leaderboard is calculated using 20% of the test data. So I provided you the test data. I asked you to submit me what is the strength of each of the samples present in the test.csv file. And I used only 20% randomly. I'm not going to tell you which one are they. I used 20% of those samples to give you a rank on this leaderboard. The rest 80% of the test samples or the predictions that you make, I will use them later at the end of the competition to provide you a final leaderboard. Okay. This is because if I combine them into one, you will not be able to get the same performance on the real world samples. Okay. It is like I am giving you a question paper. Okay. Once you go through all the questions, you know what the questions are. Even if you achieve 100%, what is the guarantee that you have the same accuracy or the same grades on a separate question paper with different questions, right? So both of them should match. That is why I have kept the data sets different, 20 and 80 split. Okay. So I will also now this is like definitely hard to understand at first. I will let's keep that for now. You can ask that uh, at the end of this webinar and we will discuss. Okay. So rules are basic. You don't need to go through any of them. Okay. And you cannot create a team for this competition. We will think about that in one of the upcoming competitions. Now, once you go into the data, you should be able to download them using this button, right? So if I download, I get the zip file, I will extract it, and I have, okay, is the VS Code visible?
Yes, it is visible, Komil.
Yeah, thank you, Dere. So the same three files that are the train.csv, test.csv, and sample submission.csv, this one, are extracted into this local folder, and I am going to demonstrate how to use them. Okay, so I have created this notebook, and do not worry because I will share all these notebooks after the webinar, so you can go through them in your own time, understand it thoroughly at your own pace, and you can submit your queries in the group. First, I am definitely importing some libraries like pandas for loading the data, NumPy, numerical Python, matplotlib, and Skiborn for some visualization, exploratory data analysis, and some machine learning related functions like linear regression model from sklearn, that is scikit-learn. First, I am loading the data sets. So if you want to make sure, okay, if the files are stored in some other folder, definitely you all know you have to provide the absolute path. If it is in the same folder, you can provide the relative path. Okay. And the sample submission. So I have named it train df, that is train data frame, test data frame, and sample submission. I'm checking the size of each of them. So you can see that we have 5,400 rows and 10 columns, as we saw on the website for the training data. We have 3,600 rows for the test data and same for sample submission. Okay, so first I am going to generate, okay, let me run this code. First, I am going to generate some summaries of the data, like traindf.info will give you all the information. For example, the columns that are present, their data types. So as you can see, there is no categorical data. They are all numerical. Okay, Hemant. Okay. Why are there three data? And it's Colab or VS Code? It's VS Code, Visual Studio Code, but you can also use Colab if you wish. You can use any you can download the code and use it anywhere. Okay. Train.csv file have the labels provided. That is the target variable. Okay. So you have to use that. This one is VS Code. You can use Google Colab if you wish. Train.csv have the labels provided. Test.csv does not have the label provided. So the machine learning models that you train, you have to use the train.csv file and train your models on that data, and then use that same model that you train to predict the strength of the samples that are provided in the test.csv. Okay. Once you make all these predictions using whatever machine learning model you create, I will share all the code. Please go through it. You have to save the predictions into the sample submission file, and you have to submit that sample submission.csv file. So, okay. Yeah, thank you, Dariya, for
So
sharing the link.
Komil,
Yes,
yeah,
Dariya.
I was just sharing it for them. So I have like one more doubt, if you can
Yeah,
tell me about it. Like,
yes.
so generally when we get data in any kind of other thing, other competition or other situation, we don't get this train data or test data. We get a single data and then we divide it into train and test. Am I right? Like generally that is how we get it.
Mm,
I
no,
guess that
see,
is why there is some
yeah,
kind of
definitely.
confusion.
See, for real world, definitely you have just one data set. You have to
Hmm.
split them into train and test so as to evaluate how well your machine learning models are doing, right? General criteria is to split them into 80-20%. Now, for the
Okay.
competition perspective, if I provide you
Hmm.
the labels already, how will I know which model is doing better? Who created the
Hmm.
better model? Who trained the better model, right? So I need to keep something hidden. That is why I am providing a test.csv file on which you have to make the predictions, which I will compare with the original predictions, which only I am having. No one is provided that. I will compare them, and based on how well your predictions are, I will provide you the rank.
Okay.
So
I
I
guess
hope I was
Hemant is
clear.
asking some doubt. Yeah, you were clear with that. Hemant is asking some doubt also. He
Okay, I
understood the
understood
data.
data.
Can
Submission
you
data.
tell the data came? Okay. So can you explain it about this?
Submit submission data or our code. No, you do not have to see. There are two types of competition. This is a simple one. There are competitions where you need to submit the code, but this one is not one of them. For beginners, everyone wants to make their competition easy by only providing the submission.csv file. And at the end of this notebook, I am going to show you how to do that. Okay. So just, let's go with the code first, and then we will clear all the corresponding doubts.
Yeah.
So as
The
I was
Kaggle
saying,
related doubts we can clear
yeah,
after.
definitely, definitely. So as I was saying, you can create some summaries here. Like if I use dot describe for each of the columns that I have in my data set, I'm looking at the percentiles, like the to get an idea of what the range is for each of the component, minimum value, maximum value, standard deviation, etc. I'm also uh, I also checking that, making sure that there is no missing data present. So I use the code traindf.isnal.sum, which is showing me 0. It means there are no rows for any of the columns that have missing data. So you do not have to worry about that. For real world competitions, you will have to deal with missing data, but to keep it simple, I have not used such a data here. Okay. But I recommend that you start practicing, because every time you are going to have to deal with missing data, and no data is going to be this clean. Okay, let's do some exploratory data analysis. So at first, I am creating a histogram, that is a hist plot. Okay, I'm going to share the code, so don't get into the details like which line is doing what. I'm looking at a distribution of the concrete strength, which is the target variable. Hopefully, this is Gaussian. Okay, and this is the box plot. So you can see there are some outliers as well. You might want to deal with them differently later when you do well on the competition initially, when you do some practice, right? Mean, max, median, standard deviation, everything. Now, the same thing that we did on the target variable, the same thing I'm doing on each of the features that I have in the train.csv file. So I am basically doing a for loop through all the features that are present in my train.csv. And for each of the variables that I have, for each of the features that I have, I am creating a histogram plot. I hope I was clear. Yeah, thank you. So
Okay.
these are the histogram plots. Now, can you find something weird here? Anyone? Like compare this three, 1, 2, 3, and this 3. Yeah, there.
I mean, I can see presence of outliers, like which are very outrageous data and does not belong to, similar range of data. That is what I can observe. There is
Yeah,
something else.
definitely. So that is one thing. Okay. The
Mhm.
range are very different. And I will show you, I will explain you later when we discuss normalization, why this is an issue or how can this be an issue. But other than that, can anyone look at any anomaly here, like something weird? Like compare this one with the second plot. Compare these first two plots and tell me the difference.
The data isn't continuous.
Yeah, definitely, definitely. So the first one is very continuous, right? There are unique values everywhere. However, if I talk about furnace slab, most of the values are zero. Same goes for fly ash component and same goes for super plasterizer component, right? And rest are normal, let's say normal, right? So why might this be the case? So it indicates that when the concrete samples are created, most of the times these variables, which are blast furnace slab, fly ash component, and super plasterizer component are not used as compared to the other components, right? This is the insight that I am getting from this histogram plots. So I will show you later how can we use this insight to increase the performance of our linear regression models. Okay, so let's keep that for now and let's create a confusion matrix. Okay, another correlation matrix. Don't kind of get scared from the matrix here. It's basically
I mean,
how
what are
much,
like, can you,
yes,
can you just tell me? I had a doubt about like what are these positive, negative values in this matrix? It's very
yeah,
confusing.
definitely.
Can you
See,
just explain?
uh, we have each of the features present in terms of columns and in terms of rows, right? So if I pick any value, let's say this blue one, that is minus 0.65, which two components are they? It is water component and super plasterizer component, right? And this matrix is symmetric. Okay. So what does that negative value mean? It means that if I increase the amount of water component, the amount of super plasterizer component automatically decreases by approximately 65%. That is what the value negative 0.65 means. If you see a positive value, it means that as you increase the value of one feature, the value of second feature also increases. Okay, for example, 0.46. Which are the two components present here? Fly ash component and super plasterizer. It means for fly ash component and super plasterizer, if I increase the value of one, the value of second feature will also increase, or the amount of second component will also increase by nearly 46%. So are the positive and negative values clear from this graph?
Yes, now it is clear.
Yes.
Okay. So I will share you a link, some resources to study what is a correlation matrix later. Okay. So you can go through them. Now let's create some scatter plots. Again, I'm not going to go into details. They are very much the same as the ones that we saw earlier. Again, you can see that there are many samples, like most of the samples for these three features that have value 0, right? I'm comparing the values of, I'm comparing the amount of each of these components with the strength. So if I train a linear regression model on each of these features separately, you will see that there is this line created. Okay, if this slope is positive, like in the first graph, it means that if I increase the cement component in my concrete sample, the strength of the concrete will slightly increase. Are you getting the point?
So I have one question. Actually, here we are talking about PMCC, right? Product Moment Correlation Coefficient. You are dealing with that,
Yeah, definitely.
right? Okay, okay, fine.
Yeah. Same way, there are some negative slopes as well. For example, water component. So, which in the insight here that I'm getting from just the single feature is that if I use water component more or not correctly, as I increase the amount of water component in the concrete sample, the strength of the concrete sample is likely going to decrease. Okay, so you can get such insights from each of these features. I will share you the code. Then let's go on to some data processing. So as I said earlier, in the trains.csv file, we have 10 columns. I'm removing the ID column and the target variable from X, and I am saving that into Y. So we have two features here, feature sets X and Y. We have to use X to predict Y. Okay, so Y is the strength or the target variable. And once again, I'm making sure that there are no missing values in the training data nor in the testing data. Okay, so this is important. Whenever you conduct some test, whether it is finding out whether there are any missing values present in the data, you have to make sure that what all experiments you are doing or statistics you are applying them on both the training data and the test data to make sure that statistic is correct for both the data sets. Okay, it might have been possible that although there are no missing data in my training set, there are still some missing values in my test set that I would have to deal with, or else my submission will fail. Okay.
I have one
So,
question. Can I ask?
yeah,
Okay, can you go back to that scatter plot, please?
yeah.
Those graphs.
Sorry,
Scatter plots, please.
sorry.
Can you go back to that scatter plot, please?
Okay, yeah,
Next.
sorry.
Yeah. Okay. Okay. Here I can see that the graph is clear cut. The linear regression is clear cut. Some of the graphs have positive gradients, some have more positive gradients, some have negative gradients. But from the scatter plot itself, to be honest, I cannot understand why it is falling in the linear regression category. Because the scatter plot is kind of, just by looking at the scatter plot, I, as a person, like as a naive person, I'm not able to understand why we are doing linear regression here, because it doesn't look like the data is following one linear trait or something like that.
Definitely, linear regression is just the simplest model we can use to solve this problem, right? I am just using linear regression to demonstrate how to use ML model here.
But
But
like,
definitely,
how we can fix the
after
gradient here?
I
I
go through linear
cannot
regression,
understand this gradient. Like
after
how
I
we.
go through linear regression, I will also tell you how to, I will also show how to use
Mhm,
random forest, decision tree, XGBoost,
mhm.
such models
Okay.
there. They will
Okay.
perform better than linear regression,
Okay.
definitely.
Okay. Okay.
So
I
linear
understand.
regression,
Fine.
yeah, okay.
Thank you.
So, okay. So this was done, right? Okay. Now coming to normalization. So as I said, as Daria mentioned, the ranges of each of the component are very different. How does that affect my model? So see, let me put a better example here. If I'm predicting the price of a house, let's say, okay, and there are two features given. One is area, that is in square feet, which would vary from, let's say, 1,000 to 10,000. Let's just assume. And I have another feature, let's just say number of rooms, right? It can vary from like 2 to 10. So these two features are from very different scales, right? Now, if I use a simple model like linear regression, what will happen is that the model will focus on the feature more that have huge values as compared to the feature that has smaller values. So before I train such models, now there are some models like decision tree that will not be affected by such difference in range, but for most of the models, it matters a lot. And hence, I'm normalizing the data here using standard scalar to get all the features into the same range. Okay. So I'm using standard scalar on X trained and the test data as well. Okay, so you make sure that you do all the transformations on training data as well as the test data and not just one of them, or else your model will just create a lot of errors. This is one of the caveats when you are starting. Then I'm splitting my training data. Now, yeah, here comes it. So I have 100% of training data, right? There are 5,400 rows for labels that have the labels present. Now, if I train my model on 100% of the data, how will I judge it? How will I compare one model with another and find out which one is doing better? So from this 5,400 rows, I am randomly taking out 20%, putting them aside and training two different models on this 80% alone so that I find out what is the performance difference on the 20% data that the models have never seen before during the training process. If I use the and a particular sample in the training data, I cannot judge my model based on that data because my model has already seen it. Okay. So if you think of this in terms of a student solving a question paper, it becomes extremely easy. I use that analogy all the time. It becomes extremely easy to understand these concepts. Okay, so I'm printing some shapes here. Okay. Percentage of training data, as you can see, 80% and 20% is used as the validation set. Validation is the term that we use for this purpose when we want to validate our model as compared to a test data for which the labels does not exist. Okay, so that is a difference between validation and the test data. Now I'm using the linear regression model. I am fitting it on the 80% data, that is X train and Y train. Then I'm using the dot predict function so as to predict the strength of the 20% samples that I earlier took aside, I put aside, right? That is the XVAL. Let me show you XVAL, right? Now I have these predictions. I am comparing these predictions with the original YVAL, that is the original 20% labels. And hence, after the comparison, I am finding out what is the mean squared error, what is the mean absolute error, what is RMSE, that is root mean square error, R square, and you can use any metric you want. However, if I go back to the challenge, I have mentioned that the evaluation metric that I am going to use in order to provide you the rank, okay, in order to judge your predictions, I'm going to use RMSE. So if you use RMSE, it is going to benefit you slightly, but that slight improvement is very important when I have to give a rank to two people having nearly the same score. So in machine learning competitions, it happens all the time that like even hundreds of people have the exact same score up to the fourth decimal or even the fifth decimal. Okay. We do not have so many people, so you will not be able to see that reason here or the importance of the metric here. But yeah, please take that, note that somewhere. Okay. So once I train the model, I am finding out these. Let me run it. Okay, I forgot to run these values. Okay, the root mean square error that I'm getting is 14.39. Now, one more thing. Once you compare whatever models you want to train, and you compare the predictions. You select which one are you willing to use. Okay. Now make sure that you are training that model on 100% of the data again before submitting it. Okay. Because right now, if I make predictions using this linear regression model on the test.csv file, then uh, the model is missing 20% of the information that was provided to you. Okay. So 20% splitting is only for comparison for yourself. Before submission, please make sure that you are training the model on the entire data set. It means all the knowledge that it can have. Now let's put a scatter plot between the predictions and the original values. Okay, so this is the actual versus prediction strength graph. Again, a scatter plot. Now, if my model was 100% perfect, 100% perfect, no errors at all the samples would lie on this x is equals to y line. It means actual strength will match the predicted strength. However, my model is not perfect. No model is going to be perfect. Okay. So I'm getting samples that are away from this x is equals to y line. It means the further a particular sample is from this x is equals to y line, the bigger the model generated the error for that particular sample. So the samples that are near this line are easy to predict as compared to the samples that are far away. It means here, or you can see here. Okay. Same way, I'm making a residual plot. So if the residuals is basically error. Okay. If I predicted the strength of the concrete sample is, let's say, 100, and it is 101, then the residual will be 1. And if it is negative, it means I predicted 99 instead of 100, it will be -1. Okay, so this is the residual plot. Again, the same. However, now, if you want to take any insights from here, one of them at this scale would be the model is generating more errors for the predicted strength higher than 55, or let's say higher than 50. Okay, like these samples. So if you are working on, let's say, even the data collection, you want to collect more data so as to train your model better, I would recommend that you find data where the where the actual strength is bigger than this threshold first as compared to the rest of the ranges. So you can find such insights through such graphs. Okay, this is the distribution of the residual. It's a Gaussian distribution. Now, the linear regression that we used also helps us see which feature plays the most important role for making the prediction. So here, I am making a graph plot of the feature importances. Okay, so these are basically the coefficients of the linear regression algorithm or the linear regression equation that was generated for each of these variables. So as you can see, the most important feature that my linear regression believes is the aging days column or the aging days feature. Now, what is aging days? Basically, in this problem, concrete strength prediction, every sample will be evaluated in one of the days, right? Either the strength will be predicted at day 1, day 2, day 3, up to 365. So according to the linear regression model, having this information plays the major role as compared to the rest of the features. Now, definitely, the reason is clear because as the age of the sample grows, the concrete strength will increase, right? Then comes superplasterizer, cement, blast furnace lab. So you can use this to compare which feature are more important and hence do some feature engineering on the more important, or let's say the less important features. Intercept is 35. Intercept is 35 and coefficients are already provided. So you can also like create a particular, uh, uh, entire equation if you want to mathematically predict what the strength of a particular sample would be.
Okay.
Yeah.
Can I ask something here?
Yeah, sure.
Yeah, for example, in this diagram, according to
Mhm.
this these observations, we are making a absolute coefficient table,
Yeah.
right? Table on the
Mm.
basis of absolute coefficient. So that means we are just getting the idea of how much importance is relative to that factor, right? Not like is it a positive kind of impact or is it a negative kind of impact? No, it
Yeah,
just
see,
shows
the
us what
coefficient
impact.
plays the positive and
Yeah.
negative role. But if I want to find out the importance, I do
Mm-hmm.
not care whether the value is positive or value
Mm-hmm.
or negative,
Mm-hmm.
because
Mm-hmm.
the bigger the value is deviated from zero, the same is the importance of the feature.
Yeah. So
If I
so
have
this
feature
is.
A with
Mm-hmm.
coefficient 6 and another
Mm-hmm.
one with -6, both of them are as
Have the
important to
equal
me.
importance. Yeah.
Yeah,
Equal importance, but from this diagram, we won't be able to tell whether that's a negative impact or is it a positive impact.
yeah, definitely. So that's why
So
I
in these
printed
kind
the
of
coefficients
scenarios,
here. Yeah,
yeah, for example, not about this because I don't know that it can be done or not. So for example, for this one, if I would have created a table, yeah, can you hear me? Yeah.
yeah.
Okay, so for example, in this scenario, because I don't know whether it is doable or not, because I'm very, see, all I can comment about the maths portion. So in this one, if I create a table just based on the coefficient, that means then that will be more, I can say, visualization of the data, because I'll be
Yeah,
able to
definitely,
tell
definitely.
which
Yes.
variable is a positive relation, is in positive relation, and which one have a negative impact, right?
Yeah,
And can
definitely.
we do that? Is it possible? I don't know.
Yeah, definitely it is possible.
Okay, okay.
You will have to change the graph that I have provided here. Like I am creating a bar plot using the feature importance. Okay. So here I'm using the coefficients directly. You can
Mhm.
use it and in terms of positive and negative separately. You can also
Mhm.
use a line in between to
And
see
then.
whether it is positive or negative, like on the left side or the
Mhm.
right side. So that will be much more informative. Yeah, definitely.
Mhm.
Okay, now I have the linear regression model trained. Yes, Vyom, you have any question? Okay, I think it was excellent. Okay. Now I have the linear regression model trained on the 80% data. Let's not forget that. Let's use that same model to make predictions on the test data. So I am saying LR model dot predict X test scaled, and I got the test predictions. Okay, so these are the first 10 predictions just to make sure there is not any error here, like null values or none for any reason that the algorithm might have failed. Okay, then I'm simply going through some statistics and let's visualize the, okay, forgot that. Hmm. What I'm doing here is I am making a histogram of the original Y values and the test predictions. Okay, now if so, see, blue one is the training data and red one is the test predictions. Now, one thing I want everyone to understand here is that the range are much narrower for the test data set. Is that help? Now, I also asked that last time also, so I hope I get some answers here. Is that beneficial for us or not? Just yes or no. I
It
repeat my
depends
question.
on
Yeah,
which context you are asking. For example, if you are checking the strength of the data, in that case, when we have the narrower range, that means the data have more strength and we can rely on the data more. And if it has like wider
no,
range but
I'm
less
saying
sample space, yeah.
the range of the strength variable that I'm getting for train data is much bigger, as you can see from the graph, as compared to the test predictions.
So as what I understood here is that you gave the blue data, right, to the system, to the model.
Sorry?
The blue data is our input here, right?
Yeah, exactly.
And the red data is the data that your model generated based on the input.
Yeah, exactly. Okay, so
So that
let me tell. Okay, let's keep. So the insight here is that the model is not generating extreme values. The model is not generating extreme values. It is failing to do so. If I do the same analysis on the validation set, I can find out how my model is doing in different ranges of data. That's why I showed you the residuals plots earlier. Okay. Using that information, I can train my model longer on similar samples or similar ranges again to train it better. Okay. Okay, so let's discuss that later. Now that I have test predictions, I am using the ID column from the test df, that is my test.csv file. And for the strength column, I am using the just created test predictions from my linear regression model. Okay. And I'm making a data print, pandas data print. I am printing what the head is. Head, it means the first 10 rows. These are the values. And I'm saving that submission data frame to submission.csv file. Okay, so let me delete this file first. Okay, so submission.csv does not exist. If I run this and refresh, I get the submission.csv file. Okay, now I'm going to go into my competition. There is this button, submit prediction. I have to choose the file. This is the one that we just created, that is submission.csv. I will upload that. And now during this competition, you always do hundreds of experiments, right? How do we keep a track, like which experiment resulted into which submission? So here you can provide a submission description just for yourself for a recap of which experiment are you referring to. So I can say I did linear regression with raw data. Raw data in the sense that I did not do any feature engineering. I do not do any major pre-processing. Okay. And I will say submit. So as you can see, I just submitted and I got a public score of 14.14. Now, as I am the host here in this competition, you will not be able to see me on the leaderboard, but it would definitely be, let's say, 15th rank. Okay, so I hope this was clear. Now let's also go to random forest and train a random forest model, right? Because it is a much complex model. We are expecting to get better results here. If you are not aware of what is decision tree, how does the decision tree regressor works, how does decision tree classifier works, I will post some links later. Okay, so that is a huge topic on its own. It would take like 2-3 hours just to uh, uh, understand what a decision tree is for decision for regression and classification. So what if a user submitting edited CSV? What do you mean by edited, Iman? He
I
has
think he
edited
means
his
editing the
source.
values.
Sorry.
But like he cannot
I think
edit
he means editing the
5400.
values.
Okay,
Yeah.
you
Yeah,
mean
like
manually editing the value. Yeah, you
Yes.
can do
like
that, but
5400.
there are 3600 values. So
Yeah,
how will you?
exactly.
Yeah,
Right.
you can do that. I'm not going to find out what you did. Yeah, edit on one basis, human versus yeah, that was what I was asking. Okay. So this is the same code. Okay, entirely. I have removed the cells where I was performing some EDA and plotting some graphs, visualizations. Rest all code is same. I'm going to just quickly run them. Same files, train, test, sample submission, no change. Okay, let me remove this one. Splitting the data and training a random forest regressor. So unfortunately, I cannot cover the entire topic. I will surely put links to lectures that explain random forest decision tree from scratch. It's a huge topic and highly recommended once you understand the rest of the code from the previous notebook as well as linear regression. Okay, so I am training a random forest regressor model here, fitting it on X train and Y train. It means training, predicting the validation. Yeah, exactly. Okay, predicting, and I am finding out what are the same errors that we use to evaluate the linear regression model. One thing to note here is that the train test split is exactly the same as I performed earlier. It means on the same data that I evaluated my linear regression model, on the very same data, I am also evaluating my random forest model to get, or it means to get a clear comparison. Okay. If these 20% data sets were not the same, I cannot perform the comparison. It would be wrong to do it. Okay, so RMSE that we got earlier, if I remember, let me just go back, was 14.39 for linear regression. And for random forest, we are getting 12.55. So definitely random forest will do better than linear regression because it is a much complex model, right? Linear regression assumes that the data is linear. Random forest does not have that assumption. Linear regression assumes that the data is 100% linear. Okay. No square, no cubic features, just linear, which is definitely wrong. Okay. So definitely random forest is doing better. Let's skip XG regressor, XG boost for now. Again, I am trying to find out what is the feature importance that my random forest model thinks for all the provided features. Which features does my model believe are more important compared to the rest? And I'm getting this feature importance graph. Now let's compare it for a moment with the one that we got from linear regression. Can I put it side by side? Not this one. Yeah, I can do that. Okay. I hope the graphs are clearly visible here. Can anyone tell me a major difference? I'm not talking about the order. Okay. Any other difference that you can, major difference that you can find?
The age in days is like considerably more important here for the random forest model.
Yeah, exactly. So for the linear regression model, every feature are evenly, evenly important, more evenly important as compared to the random forest. So random forest has given much more importance to age in days as compared to the rest of the features, comparing with the linear regressions distribution for the feature importance. If you know how decision tree works, you should be able to understand or reason why. So I believe many are not aware. So let me just say, linear regression creates a linear equation, right? It does not discriminate between every feature. However, in decision tree, at every split that the decision tree makes, it evaluates all the features and then only keeps the most important one. Are you getting my point? So if it keeps the most important one only, deleting the rest of them, importance should definitely be more for is the most important feature for random forest as compared to linear regression. Okay, so let me again put it here.
Excuse me.
Yes.
Uh, in previous slide where you differentiate random forest and regression.
Yeah. Yeah, you want me to? Yeah, okay, wait. Okay.
It is not a decision tree which are
No,
on right side.
random forest is basically training 100 decision trees and then using each one of them parallelly to generate the predictions. Okay, so that's why it's called forest.
Means
Okay,
forest
tree, multiple trees,
random
forest.
tree
Forest of trees.
Yes.
random
Yeah,
tree
Sorry, you
forest
are
comes
of
not
under
audible.
trees.
random tree comes under decision tree comes under random forest.
Yeah, exactly, exactly.
Okay.
Okay.
Like decision tree alone is also a thing. It's also a
Yeah,
model.
exactly,
But
exactly.
when
So
you
I can,
combine a lot of decision trees, then you
yeah,
make it a random forest.
yes, exactly. That's why it is called forest. So that is one
Yes,
very good analogy, right?
yes. It is like single people attempting test at their homes, and then they get along together. All of the 50 people are giving the test at the same place for the same thing, and then they give one single answer as output.
Yeah,
Their
exactly.
answer is
So
their
yeah, so
answer
let's
is
talk about
more
it a bit.
closer.
Let's
Yeah,
talk about it a bit.
their answer
Okay,
definitely.
let's assume a scenario. Let's say in a particular hospital, there is some patient having a disease X or not. We don't know. There is one doctor present there. Okay. And in another hospital, same patient is going, and there are 10 doctors. These 10 doctors will make a prediction, each one of them, and they will do basically a voting. Okay. Tell me which one is better. Definitely the 10 doctors team, right?
Yes,
Because you can
definitely.
rely on majority more as compared to the decision made by a single doctor,
Yes.
right? So that is the same thing that is happening. If it is regression, if it is regression, you what you normally do is take the average of predictions made by
Average of.
each one of them.
Hmm.
If it is classification, you do voting. In both the scenarios, the team will definitely do better than a single model.
So like if we speak statistically for classification task, we take the mode from the output, right? Like mode of the whole output they have given. Like let's
Mm,
say if there are like 25 people here and we vote like which teacher according to you is best for trimester 3. If 20 people say it's this teacher and 5
yeah,
people say something
exactly.
else, it's
Exactly.
20 people's vote that counts. So that kind of a scenario is with decision trees. And if you
So
ask
basically,
individually, somebody will say, yeah, that is how it is.
yeah,
Continue.
probability that the majority does the wrong prediction is much
Is less.
less than the
Yes,
probability that a single person will do the wrong prediction,
wrong prediction. Right.
right? If the entire
Hmm.
team needs to fail, 6 doctors at least will have to do
Hmm.
the wrong prediction
Yes.
as compared to only one on the other side,
Hmm.
right?
Yes.
So team always wins. Okay. This is the distribution of feature importance. I'm not going into details here. Okay, we can discuss this later. I am again making predictions using the same code that I did earlier. For linear regression model, no changes in the code. Only the name of the model changed from linear regression to RF model. Again, saving the predictions. Now let's provide it a different name this time. Let's say submission underscore RF. RF is random forest. Okay. Submission, and let's see if the file is generated. Let's refresh. Yeah, there we go. Submission dot underscore RF. Let me quickly go back to the competition, submit prediction, and use submission underscore RF and submit. Definitely, we should get a better performance than the linear regression model. Okay, earlier we got 14.1 using linear regression, and now using random forest, we are getting 13.05. So I got a better rank. Imaginary better rank. I am not on the leaderboard. Okay.
Yes.
Let's see. Now, okay. So I discussed this earlier as well, that here in the aging days column, one thing that you will notice is that the unique values are much less as compared to the rest of the features. Rest of the features are more evenly distributed. However, this one barely have 10 to 12 unique values, right? It is 0, 1, 2, let's say 7, 50, and there are lots of missing space in between. Can we use it? Yes, because uh, if I have sample A whose strength was evaluated after X days, let's say 10, and if I have another sample, concrete sample, sample B, which was evaluated after 15 days, not 10, can I compare these two? No, right? I have to compare them after same number of days. It means their age should be same, right? So can we use this information to improve the performance of linear regression model? Let's see. Almost again the same code for linear regression. That is the first notebook. Importing the libraries, loading the data. If I do train the app age in days dot unique, I see there are only 12 unique values, which are 3, 28, 365, 90, and so on. Right? So let's say, let's just pick one number here. Let's say, what should we take? 4. No sample was evaluated on day 4. No sample was evaluated on day 5. Okay, so all the samples that I have were evaluated only on one of these given days. Can I use this information? For each of the unique values, I am running a for loop. Okay, the code is self-written, extremely easy. Copy it. If for each of these unique values, I'm basically creating a new feature mentioning whether a particular sample was evaluated on day 3 or not. It's a binary feature. Okay. If I have 12 unique values here, I am basically creating 12 unique features. Each one of them mentioning whether I whether I evaluated that sample on that particular day or not. Okay, so simple code. You can see these are the new features that are created: age in days underscore 1, age in days underscore 120, and so on for each of the unique values. I used these, okay, I added these new features to my dataset. Let's now train the
So this
same
is
model.
one hot encoding.
Sorry.
One hot encoding.
Yeah, exactly. One hot encoding. So just for the demonstration purpose, I used manual code, but please use one hot encoder if you know it. Okay, great. Thank you, Ratan. So data processing, pre-processing, same standard scaler, same splitting the data, again using the same split, and training the linear regression model. X train, okay, X scale. Oh, I forgot to run this cell. Yeah. Yeah, now it will work. Sorry for that. Let me check what is the issue. Yeah, there are just 8 features. Why am I getting 8 features? Okay, now it's correct. Yeah, now it's perfect. So I added these features as I explained earlier, and now the perform. Yeah, Suman.
I don't understand age in days.
Yeah, okay. See, I am basically categorizing my data to put it into one sentence. Okay, I saw that the age in days
Yes, yes,
column.
you age in days here. Your high
Okay, so you are not aware
means
like
you
what is the feature representing.
age in days is feature of your CSV means, but you are dividing age in days in 10, 15 attribute I means.
Yes, exactly. So I have these many unique values inside my column, right?
Yes,
For
yes.
each of these unique values, I am creating a separate column, a separate
Means
feature.
one hot, one. You are using one hot here.
So
One
yeah,
hot.
exactly. One hot encoding.
Okay, okay, understand.
Okay. So for demonstration, I wrote the code manually, but you can use one hot encoder. Highly recommended. Now, using this small change, the performance that I am now getting using the same linear regression model, no difference, is 11.85. Earlier, we got 14 point something, right? Using the raw data. And using random forest, we got like 12, I guess, 12 point. If you
13.8 something.
no, that was on after the submission. Right here, it is
Oh, okay.
12.5, right?
Yeah.
On this 20% data for the same comparison. Okay. And now using linear regression, I'm getting 11.8. So using this insight from my data, I am able to beat random forest using linear regression. Are you getting my point? So let's see if the features that we just created are important to my linear regression. They definitely are. Okay, these features that I just created, aging days underscore 3 underscore 7 underscore 56, one hot encoding. Please, I will share some resources for that. These features that I created now are turning out to be the most important for my linear regression model, right? Hence increasing the performance. So whenever you add some feature, whenever you think like, okay, if I create this feature, it should increase the performance of my model. Please find out how much your model uh, takes the feature into account by looking at the feature importance, right? Look that is the newly added feature important for your model or not. Okay, so this is a trick to do that. Definitely, there are much more experiments that I encourage you all to do it. I will also share some ideas, but without the code, okay, leaving you to do it and discuss it in the group as well. Let's create the predictions on the test set. Again, the same graphs. And let's say, what should I say here? One hot, okay, submission underscore one hot dot CSV. Let's see if the file is generated. Yeah, there we go. Let's submit it. Now, why am I doing it? I want to make sure that the performance that we just saw is actually true. Okay, it means the same performance should be able to, we should be able to see the same performance on the submission as well. Let's submit. Submission one hot. Let's save one hot. Encoding age in case. Submit. That was definitely true. So 11.93 is much better score than 13. It means my model did not just do well on the training data, it performed the same way on test data as well. Very important test. If this is not true, it means the feature that you added is only beneficial for your training data and you should not use that feature. Okay, it will overfit your model. Great. So let's discuss one more thing. Now, let me remove the standardization. You can also use the raw
Well,
features without normalization. Yeah,
can we answer this really great doubt asked by Meenakshi? I will ask you the question. What if the test data set has a value other than these encoded from trained data set? We also need to keep in mind to keep else if block also, right? So I guess we need to tell them about imputation and noisy data and stuff like that. So if you have some knowledge, please do share on that.
yeah,
Like
exactly.
if
So
the
it definitely
noisy data
happens
is,
many
yeah,
times that test data is slightly different than the training data. Let's say that the modification that I just made, the unique values for uh, aging days are these many, right? Let's say if I try to find it for test DF, let's say test data set also have uh, some unique values, let's say 5 that are not present here. Okay. So what will happen to them? There are many ways to deal with such data. Either I can put a none there or just some indicator that this was not seen during the training data. The better way to do it, of course, don't do it here. I mean, not on. I have already made sure that it is not the case, but just for explanation point of view, better way to do it is to first combine both the data sets into one huge data that is train plus test CSV. Okay. And then you do such one hot encoding. Are you getting the point? So if there was some samples with aging days 4 or 5 that are missing here, that will also be taken care of if I first combined or merged these two data sets and then performed the pre-processing. Yes, thank you, Meenakshi.
and I have a doubt after this
Yeah.
doubt. Uh, like, what if the data, like the trained data which we are given is noisy, and the test data which will be tested privately is not as noisy as the trained data. So how can we train the model that it generalizes way better? Because that is our end goal, right? To build a generally like good model.
Definitely.
So
So,
what are some
yeah,
methods which we can use?
exactly. So there are many ways to deal with overfitting. What you are talking about is basically overfitting, right? How to avoid overfitting. If I check the performance difference for the linear regression model between the score I got and the one after I made the submission, what is it? Let's see the score here. It is 11.85, right? And what did we get after submission? 11.93. So it is small. Okay. Keeping that in mind, if I compare the same thing for random forest, what is the difference? We got 12.55, a score of 12.55, but now we are getting 13. Huge difference, right? Why? Because random forest tends to overfit more than linear regression model. If I wanted better performance, instead of using max depth equals to none, I would have constrained my model in terms of complexity by limiting the depth of the decision trees. I might have, let's say, did 5. Max depth is equals to 5. Okay, that is maximum depth of the trees. As you can see, that is also providing me a much better score, right? If I now do a submission let's say RF2. Okay. Quickly submit it in the competition. Did you see? So same performance,
Yes.
the gap between the training score and the score I get after the submission, the gap decreased significantly when I decrease the complexity of the model. The more the model is complex, the bigger will be the gap. Okay, which is bad. Okay, so keep the complexity under control to avoid overfitting. If you find that even a max depth of 5 is leading to a huge gap, then you can decrease it further to, let's say, 4 or even 3. Okay. So in short, decrease the complexity. It's not just depth. If you are working with linear regression, you can use errors like uh, uh, regression alpha, regression lambda, that is L1, L2, right?
But like these regularizations comes
Yeah,
like it
exactly.
is kind of
Regularization.
the this is like the later part of optimizing. First, we need to build a decent model which has decent accuracy and like decent, I would say, performance on general data, and then we opt for optimizing it for better and better results. Sorry, I mean
Exactly, exactly.
regularization
Yeah, right.
techniques.
If
Hmm.
I find out that training, even my model is doing phenomenally, phenomenal on training data, that does not guarantee that it will perform the same on the test data. And that's where a concept comes out that is called holdout set. Holdout set is another split from the validation data. Like I use 20% validation data, right? I will use another 5%, a small one, and name it holdout set. I will use that holdout set to find out such overfitting. Because see, I am hosting this competition, right? Now that's why I am showing you this concept by submitting to the competition. But as a result, I lost submission as well for today. Every day, everyone gets 5 submission. I just lost one just to find out about overfitting. How to avoid that? Use a holdout set from your training data only. Okay. I guess we were here. Yeah. So what is the okay standard scaling? 11.85 is the score right now for linear regression model. Let's try one more thing. We saw in the scatter plot and the histogram plot at first that these 3 features have majority values 0, right? It means most of the time they are not used for creating the concrete component. So let me create a indicator column for each of these 3 features, indicating whether that component was used or not. Just simple. 1 or 0. 1, it means yes, the component was used no matter in how much amount. And 0, it means no, it was not used. Okay, so let's run the describe. And yeah, from 25 columns earlier, now I have 28. So I added 3. Pre-process the data, again 20. Okay, forgot to run that. Okay, 26. Okay, so we have these new features here. Indicator columns like blast furnace slab underscore used. It means whether that component was used or not, uh, without the information about the amount of this component used. Okay. I only care about this binary indicator, not the amount. Let me copy paste and run it again. So yeah, earlier the linear regression was getting a score of 11.85. Now it is getting 11.83, doing slightly better, right? So again, you may not find the importance of the second decimal in this competition, less participants. Probably in the upcoming wish, I hope, probably in the one of the upcoming competitions that we host, you will be able to see the difference, and this difference plays a role. Let's also find out the importance. Okay, what is the importance of the just created features? The used indicator columns. So it is coming right here, right? Blast furnace slab underscore used, super plasterizer component underscore used. And let's see where are the actual raw features. It is here, super plasterizer component. So what do I get the insight about this? It means that just the information about whether super plasterizer component was used or not in the concrete sample is more important to me as compared to the amount of that component used. Same goes for the other features as well. Okay, so I also reasoned why I got a slightly better performance this time, right? Again, you can make the predictions and run this code, submit, right, to get a better score. I'm not going to do it. I just have one submission left. Let's keep that. Let's keep that for some doubts. Okay, so one more thing. If you want me, I can tell you the importance of evaluation metric. Do you want me to discuss that, or like how can I benefit from multiple uh, evaluation metrics at the same time, or you want to jump ahead to discussions?
I mean, let's have a quick discussion of like evaluation metrics importance in terms of both classification and regression. Like both of them have different evaluation metrics. So let's just have a quick discussion and then we can on to the discussions and Q&A or doubts what we have. So we can discuss on.
Mhm. Right. So for classification, definitely there are many ways how you can find out the performance of your model. Accuracy is the worst. Okay. Accuracy is the most commonly used, but it is the worst. And if you know about recall, precision, F1 score, you will know what I am talking about. So again, not going to that detail, but let's just say that for regression, uh, evaluation metrics matter less as compared to for classification. Okay. Now, what I actually wanted to present is that when you change the evaluation metric, like I can use RMSE, that is the evaluation metric of my competition, or I can use ME, that is mean absolute error. Okay, both are different. What change does that make to my model? my model changes its focus. Okay. So for different metrics, it might want to focus more on some particular samples as compared to the other ones. Does that give me a benefit? Yes. If I train one model on RMSE, another one on MAE, and then take the average, that should give me a better score than the RMSE model alone and the MAE model alone. Reason, again, the doctor analogy, right? So let's consider that these doctors are trained from different universities, let's say. How does that analogy sound like? Better, right? So this is the code I have already created. I can either go through this or it is just what I have. Uh, it is just the proof of what I have just explained. So I can do it mathematically just to show you that yes, indeed, what I just mentioned is true, or I can jump to discussions.
We can choose from. In what people, majority people say, if yeah, anyone can
Yeah,
answer
please
that.
say yes or no in the meeting chat, everyone, if you can. Yes for yes,
Komil,
please go through
somebody
the
has a
code.
doubt. Somebody has a doubt. Somebody has some
Uh,
doubt. He's speaking.
Yeah, so I was saying that RMSLE model will
sorry,
give a
it is
better.
not audible, Tushar.
Just give me a second. Is it audible now?
There you, if you can pass on his query to
I
me.
can. Yeah,
Yeah,
I can
please.
hear you. I can hear
Because
you. Tushar. Just tell
my
me what
speaker
is
are
your
not
query.
that
I
good to
will.
me.
I'll just type in the chat. I'll just type in the
Okay.
chat.
Yeah, you can type in the chat. That is also good. That is also good.
Excuse me. I
Yes, Suman.
Yes, Suman.
I have one doubt.
Yeah,
Means when we train model,
yeah.
we do visualization, but means we do visualization for finding uh, level value, for differentiating feature value and level value. We do visualization.
Sorry, can you, there or Aryan, can you,
Okay. So I mean, what I understood from your question is that whenever we are making model, we visualize the data. Why we visualize the data? Is that your question, Suman?
We visualize data for finding level value and feature value.
Okay.
Our
Okay. He's
main purpose
asking.
of visualization is that we find level value and feature value.
Okay. So, Komil, his
yeah.
question is, what is the purpose of visualization of our data? I mean, label value, like importance of feature, importance of labels. What are the different kind of, I mean, what is the importance of visualization data while training a model? If you can explain it.
I,
Like, am I right, Suman? Is this the query?
No, no, my
yeah,
means
wait,
is that
I think,
we we
yeah, please.
we extract level values from
Okay.
from data.
Wait, I think I get
This
it.
is our purpose of visualization, or not?
Yeah, his
Okay.
question is that do we use visualization to get the values of features and labels, like to see the exact values? It's his question.
Uh, Not actually, I would think. I mean, what we
It's just,
use generally
yeah,
visualization for is to have an idea of the data we are working with. Like, there are some basic statistic numbers that we would want, like range,
See,
mean.
first, when I made the histograms and the scatter plot, I visualized the data, and based on that, I made some hypothesis that yes, these and these features can help my model better. Then I created features from that visualization only, which I would not have got from statistics alone. And that made my linear regression model beat the other models like XGBoost and random forest trained on raw data. So visualization is important. Tushar is asking RMSLE model would give a better result, right? Correct me if I am wrong. RS, okay, RMSLE is RMSE, but on logarithm scale. Okay, so they are used particularly when the data is quite exponential. Okay, most of the values are that matter more are in a shorter range as compared to the ones that are far apart. So you can try that. I am not sure for if that will be true for this particular data set. We use plots to visualize and see the data as we cannot actually notice patterns by looking at those tables. Exactly.
Komil, I had a doubt.
Yeah, Ratan.
We created the scatter plot and we saw the outliers. So, if the number of outliers is low, so can we identify those rows of the values so that if it's low, we can remove that from the data so that the model may perform better?
Yeah, definitely. See, I am sharing personal experience here. There are competitions where I removed the outliers, which helped my model at first. But since those outliers were also present in the test data, I got a worse score after the submission. Okay.
Private, like the private score was not as good. I mean, you are not generalizing your model. You
Yeah,
are just
exactly.
over
Because
kind of overfitting.
in the test
Kind
data
of
also, I
overfitting.
have those outliers. I cannot remove them, right?
Yeah.
So I have to train my model for dealing with those outliers.
Yeah, but if the number of outliers is large, then I think it's understandable that it affects the test also. But if it's too low, the number is low, then I think it won't affect much if we remove them.
I mean, if I can answer this question for me,
Yeah.
I
Yeah,
mean, I have some things which are like this is a discussion, so we can keep it.
yeah, please. This is for discussion.
I, I mean, what I think of this as that rather than removing the data like outlier or data which is not near the mean, what we are doing is we are not helping our model. We are making it, worse in terms of generalization. We are making it really specific that if the data is, let's say, uh, 3 sigma or 2 sigma from our mean, then it performs good. If there is something outside that, it performs really bad. I mean, what actually can happen if you get a data from real world? If like, let's see, if you are computing something and you get something very really outrageous, when your model holds, it's like a question mark. Like you studied for the algorithm test and you were asked question from data structures or R, that kind of a thing it is. Okay, it is completely
See,
uh
there are two types of outliers. Okay, let's just
hmm,
forget the amount of outliers that are present. Okay,
yeah.
the rule
Hmm.
applies to both the scenarios, whether the amount of anomalies are small or more. Outliers and anomalies are different. Outliers might also mean that if I'm predicting the house price, majority of the houses for which I am predicting the price in my data set are up to 10,000 square area or square feet area. Okay. And there are some outliers that have, let's say, 15,000 square feet or 20,000 square feet. These are outliers. I should not remove them, whether they are small or big, whether the amount of them are small or big. Okay. However, anomalies mean there is some problem with the data collection. Let's say someone mistakenly or accidentally inserted some huge value. Instead of 10,000, he put 1 lakh. That I should remove. Okay, this is the summary.
Okay,
You
okay.
can see
Yeah.
type of plots X versus Y plot.
Meenakshi has a doubt.
What are used in most cases, and what do we conclude by this plot, which cannot be done by other plotting examples? Share some examples. Okay, there are different plots, histogram, scatter plot. I already showed you the importance of each. Scatter plot, I can also combine them with linear regression as I showed you the lines, right? The slopes, like how does a particular feature help me predict the strength? So that helps me to understand how to understand the data and to understand the problem. I am not sure how each one of the features are going to help me. These plots are going to help me do it. Along with the feature importance plots, as it was earlier discussed as well, you can use positive and negative plots for the feature importance to find out whether the coefficients are positive or negative. Then let's say one important thing like example is violin plot. If you use a box plot to find out the outliers, you do not get any idea about the distribution of your data. However, if you make a violin plot, you also get a beautiful violin indicating where majority of your data lies, up to which range, the uh, importance or the amount of outliers there are, their own distribution, and a lot more details. Okay. So I have already shown many examples here as well. This is one more. We
So
can
like
also do it later.
violin plot.
You okay.
So yeah, violin plot is basically box plot made beautiful, if I am not wrong.
Yeah,
It's
exactly.
similar to
Box
box plot.
plot plus
Yeah,
histogram is basically
yeah.
violin plot.
It's basically violin plot. Yeah.
Yes. Any other questions? So I think we have already
Okay, okay. I have just one more question. Uh, Sorry
yeah,
for
yeah,
making it late if it is. I mean, let's just not talk about this competition. In general, ML
yeah.
model stuff for an ideal model, which is doing good. Like, let's say we have been assigned to a task at our company that we have to build a model. These are the data sets, and it will be a real world data, right? It will be a real world data. So, like, it's a regression task only, let's assume.
Yeah.
So, what are the things that our model should do? I mean, an idea in general, performing model should do. I mean, what
What
all
it
qualities
should
it should
do,
have?
I mean,
I mean, what all qualities it should have? Like, it should be. Uh, I mean, we know about generalization, but we need to
okay. Yeah, now I got it.
understand how much.
Yeah, I get it.
Yeah,
So one of the parameters is definitely generalization. It should not overfit on one data as compared to the other, right? It should generalize on the real world evaluation as well. You can think of it as a beta version, right? So whenever an app launches, you get the beta version
mhm,
first as compared to the official version. And they say that,
yeah,
see, you are going to get some errors here, some bugs here. So you can try out that as well. You can publish the model in a beta version to find out if it is doing correctly on real world or not. And you can train it again if it doesn't perform well. Okay. So one is generalization. Another one is definitely accuracy. So if two models are completely generalizable, select the one with a better performance. Simple, right? Another one is explainability. These linear regression model, random forest models, are giving me ways to directly find out which features are more important, right? That might not have been true if I used a neural network, because neural networks are black box. Of course, there are some complex methods like GradCam, if you know, uh, dealing with the gradients to find out the feature importance, but apart from that, I do not have this. Linear regression, if the performance of a linear regression model and a random forest model are the same, which one would you use? Linear regression, right? It gives me an entire equation that I can also use it in a calculator and find out the results. So that is explainability. So again, important. Yeah.
Okay, got it. Anybody else has some doubts, so they can.
Yeah. So we do not have time to, go through this. I already explained the concept, but we cannot go through the proofs. So any more doubts that we have regarding the competition, or I suggest ask questions more in general regarding ML, because that is what this webinar is for.
So are you considering to extend the deadline now?
Yeah. How many are present here who wants the deadline to, who wants me to ship the deadline? We can do it by a few more days, like 5 or 6 more days. Okay. One, did Aryan Hemant is saying yes. 3 yes. Let's say 4. I believe there is no one who wants the competition to end in the current deadline. Yeah, okay. I will increase it. Okay. I will make it up till next Friday. Sorry, next to next Friday, not next Friday, next to next Friday. So you still have 15
So
days.
a week extra, yeah.
You still have 15 days to work on it. I hope everyone is able to join the competition, right? Let me see how many people have joined. There are 28 entrants. I believe you all were able to join. If not, please tell me so that I can share the link. Okay, let me just do it. Copy, paste. There you go. Yeah, Soumya, you have a question, or you are saying yes, increase the deadline?
Nothing. I was just saying yes to increase the deadline.
Yeah, okay, okay. Okay, any more questions that we have? Or you can, I'm not good at teaching maybe, but please put some rating so that I can know. Let's say from 0 to 10. What is one hot encoding? It is the same thing that I mentioned about age in days column that I performed manually. Okay. But one hot encoding, there is a class. Okay. Yeah. Wait. Let me put it here. One hot encoder cyclic. So you can use the same one hot encoder class from scikit-learn as well, and that will do what I did manually for age in days column directly. Okay, so concept is the same. If you want to read more about it, you can do it. It's basically categorizing, right? Yeah, I will share more resources, please. Just 2 ratings till now. Thank you for the 10s. We can have more discussions, or we can have some ratings so we can end the session. Thank you, Suman. Since there should always be some scope for improvement, definitely. Definitely.
Love these perfectionist people. Love it, love it. 9 on 10. I will say
Definitely.
19 on 10.
Thank you,
I will
Daniel.
also give some rating. I will also give some.
Yeah, please do. Also, I will. I have recorded the meeting. Okay. I I will share it soon. I will also post a summary of today's session on LinkedIn. If you can give your honest feedback, whether you like it or not, I do not. I'm not forcing you to put some positive comments there, but please react. Okay, react and put your honest comments there. Hope you become one of the best. Thank you, Tirtha. Thank you, Yarish. Use Google for understanding complex things with visualizing concept. Yeah, why not? Okay, so any more queries or we can end the session?
I think we should end now. Most of them don't have any queries.
Yeah, exactly. So let's end the session
Yeah.
now. I hope you all liked it. Okay, then see you everyone in the next webinar. One more thing. The next webinar will be after the competition. Okay. If you want another webinar in between to clear some more doubts, that will not be a retake of this one. I have already recorded it. I will share it soon. If you want something in particular, please share what all content should I use there. Okay. And tell me the content for the next webinar and we will host it in the upcoming week. No, there is no benefit on Kaggle from IIT email, Tirtha. One of them would definitely be that you have some more, creditability. Let's say more genuine. You sound more genuine if you when you comment something in the Kaggle discussions. So that can
People
be
will
one
take you
benefit.
more seriously.
Other than that, there are no any official benefits. Let me stop the
You can
sharing
have
and
difficulty getting your
yeah,
account
Ratan.
back. You can have difficulty getting your account back if, in case, after 4 years, this email would stop IITG.
Yeah, that is one thing, definitely. But I guess
Yeah,
the email stays with us as far as
now
I am aware.
they have mentioned that this OP1 email would be taken back, and another would be provided. I guess it was
Okay,
mentioned.
yeah.
Yeah,
Thank
Yeah,
you for informing that. So in that case, if you are making any account using your IITG email, I recommend that you also put your another personal
alternative email.
email for the same account so that you can easily have access of it after 4 years. Yeah, thank you, Ratan, for mentioning that. I wasn't aware of that.
No problem.
Thankfully, I have not used anywhere. Thanks for providing the info. Okay, then see you everyone. Thanks for all the feedbacks as well. Okay, bye and happy Independence Day.
Yeah, same to you, same to all.
same to
Same
you,
to
bro.
you.
Bye. Bye.
How to stop the recording? Okay, got it.
Recording